Fine. So this is for basic reaction for adding chlorine, for adding cyanide, for bromide, for iodide. There are other reactions that occur on this. For example, if you add warm water, just add warm water and do nothing. This warm water is going to increase the temperature of the system. Nitrogen gas is going to come out, water is going to attack, and you will have a OH instead of this N2 plus, and this is going to become phenol, like this. If you add, suppose, HBF4, if you add fluoride ion in a form of complex, this is H plus, this is BF4 minus. Now BF4 minus has fluoride ion, and that fluoride ion is in a form of complex. That fluoride ion, this boron is going to release fluoride ion in a controlled fashion, and the reaction of fluorine is going to happen in a controlled fashion, and this fluorine is going to be added and you'll have fluorobenzene. Fine. If you add hypophosphorus acid, if you add H3PO2, now in H3PO2 the charge, the oxidation state of phosphorus, if you can figure out, is +1. There are 2 oxygen will give -4 charges. There are 3 hydrogen plus 3 charges, plus 3 minus 4 gives you -1. So this -1 has to be balanced because the overall molecule is neutral. The phosphorus got to have +1 in order to balance this -1. That's how you get the charge of phosphorus. This is +1. The stable oxidation state of phosphorus is +3 and +5. This +1 is unstable. The phosphorus will try and reach the higher oxidation state, and it will lose electron. When it's losing electron, it's getting oxidized. So it's going to reduce the other substance present inside. So it's going to act as an reducing agent. So this is going to reduce this diazonium salt. That means addition of hydrogen. So this diazonium salt is going to turn into benzene. When you add a hydrogen here, it becomes benzene. So that's the purpose of adding hypophosphorus acid. One more thing, if you just add sodium nitrite, this is going to turn into a nitrobenzene, like this. So this is the basic 8 reactions that you have to study concerning this diazonium salt. Now this reaction is very powerful. Now wait and observe. From this diazonium salt you can get phenol. You'll have plenty of reactions on phenol, plenty of compounds that you will get originating from phenol. So you can get all those things from aniline once you get diazonium salt. Now you can get chlorobenzene. Now lots of reactions occurs on chlorobenzene. Chlorobenzene is a starting material for various other compounds. So you can get all of them if you got aniline, and you could prepare diazonium salt out of it. Now here you have cyanobenzene. This cyanobenzene can react with Grignard reagent to give you ketone. This can be reduced to give you amine. That can be further hydrolyzed to give you aldehyde. This can be hydrolyzed directly to give you carboxylic acid. Benzoic acid becomes the starting material for various other compounds. So you can get all of them from this diazonium salt. Similarly, other halobenzenes, this can be coupled and this can undergo dimerization reaction to give you biphenyl. You can reduce it to give you benzene and all the reactions on benzene. You have a nitrobenzene. Nitrobenzene acts as a solvent because this abstracts electronic density from benzene and makes the reaction sluggish. So generally reaction do not occur on nitrobenzene. Nitrobenzene acts as a solvent where the solvent don't have to interact with the reagent. So you can prepare nitrobenzene from this diazonium salt just by adding sodium nitrite. Fine. So here you can begin and you can end to various other compounds. So it becomes an important starting point to reach to various other compounds. So this diazonium salt becomes a very important compound or a starting material for the preparation of various other organic compounds. So it's a very important reaction and it deserves some respect. So you learn it, you pay some attention, you pay some time into this reaction, try to absorb what are these 8 basic reactions and what you are getting it, and try to think what's going to come ahead, because surely there will be some reactions I'll be giving you where some reaction will occur on cyanide. and the cyanides reaction we have seen, where some reactions will occur on phenol, and all the reactions of phenol we have already seen. So there will be a recapitulation, revision of what we have done already. So let's solve some problems and things will become more clear from there. Suppose let's begin very humbly, starting with small problems. Suppose this is nitro, or you don't have to suppose, it's actually nitrobenzene. From nitrobenzene, suppose you have to reach to benzoic acid, and you have been asked to carry out the conversion or to figure out the pathway through which a chemist will convert a nitrobenzene into benzoic acid. Then figure it out on your own and carry out the conversion problem. Now, one hint or one thing that you have to keep in your mind, that somehow if we can get to diazonium salt, then from diazonium salt you can prepare whatever you want. So try and get diazonium salt first of all. And diazonium salt you can prepare once you get to aniline, because we prepare diazonium salt from aniline. So if you can somehow get aniline from nitrobenzene, then your job would be done. Now in this chapter, when we studied the method of preparation of amines, we studied that nitrobenzene can be reduced to get you aniline, or nitro group can be reduced to give you amine group. So this reaction is well known. So very quickly you'll convert this nitrobenzene to aniline, and aniline will carry out diazotization reaction, keeping the temperature very low so that the nitrogen gas is not released yet. Now from this you can add cuprous cyanide to give you cyanobenzene, and this is well known that when cyanide is hydrolyzed you get carboxylic acid. So hydrolyze this cyanide and that will fetch you the desired product, that is benzoic acid. Fine?